Hello, welcome to this clip looking at calculation of reactant quantity from percentage yield. It's a leveled response question walkthrough, and it also includes a little bit of organic synthesis techniques. So let's have a look at reading and thinking about the question before we get cracking. So this is our question, and there's quite a lot of information it gives us, so we need to think for a moment about what the information is there for. So the first thing to look at is the data that's given to us about the various liquids that we're dealing with. So we've got hex-1-ene and we've got hexan-1-ol. So they give us density data so we can compare them with water. We need to do that when we're thinking about separating them out. Obviously, if they're denser than water, they'd sink to the bottom of the separating funnel, and if they're less dense than water, they'd float at the top. So it's expected that you can remember that the density of water is 1 gram per centimetre cubed. You also have boiling points to allow you to see what temperature to collect the product at during distillation. They give you the equation for the reaction, and I'm going to convert each of the skeletal formula into structural formula from now on, just for simplicity. And the equation is provided so you know the mole ratio of the hexan-1-ol to the hex-1-ene. But then after reflux, it says the resulting mixture contains unreacted hexan-1-ol, hex-1-ene, and water. So there's 2 organic components and 1 aqueous component. It says the mixture is purified. So you now need to think about what separation techniques might be needed to separate out organic and aqueous liquids from one another. Then it says the expected percentage yield of hex-1-ene from hexan-1-ol in this reaction is 62.5%. And the student plans to make 4.2 grams of hex-1-ene by this method. You need to think about the moles of hexan-1-ol needed to achieve this, taking into account that percentage yield. So to calculate the mass of hexan-1-ol and explain how you could obtain pure hex-1-ene, you need to read that part of the question so you know exactly what this needs to do. So what's required of you is the mass of hexan-1-ol, taking into account the percentage yield they give you, and any purification steps that might be necessary. So let's now plan and construct our answer. So we've reproduced it on the left-hand side there, and I'll take you through the thinking points that might be helpful for you. So first of all, make sure you put in subtitles that answer both parts of the directions, otherwise you might forget to do one of them. The danger with this type of question is if you don't do one of the 2 things you're asked to do, you'll then lock yourself out of getting the higher levels. Remember, it's level 1, level 2, and level 3. That is level 1 being 1 and 2 marks, level 2 being 3 or 4 marks, and level 3 being 5 or 6 marks. So you want to give yourself the best possible chance of getting a high number of marks on this, obviously. So you use the equation as a starting point. 1 mole of hex-1-ene can be produced from 1 mole of hexan-1-ol. So to work out the number of moles of hex-1-ene that we're trying to make, it's 4.2 grams. So you divide that by the molar mass of 84 grams per mole to give you 0.05 moles. Now to deduce the moles of hexan-1-ol that would produce this, assuming a 62.5% yield. So you take the 0.05 and you multiply it by 100 over 62.5, and that gives you 0.08. So now I need to multiply this value by the MR of hexan-1-ol to obtain the mass required as directed by the question. So doing so gives us 8.16 grams. So now I need to think about what you're told is in the final mixture and how you would separate these out. If you remember, there's hexan-1-ol, hex-1-ene, and water. So there's 2 organic and 1 aqueous component. So the different boiling points are far apart enough to only need 1 distillation, but the presence of aqueous and organic components will need a separating funnel and a drying agent. So you need to state that you're using a separating funnel to collect the upper organic layer in the mixture. It's less dense than water, so it will float on top of the aqueous layer. Before you use a drying agent such as anhydrous CaCl2 to remove any final traces of water. Then you decant the organic layer remaining into a pear-shaped flask and distill, removing the fraction that comes off at 63 degrees C, which is this hex-1-ene that you're after. Okay, I hope this has been a useful clip. It's one way of going through this type of question. Until next time, thanks for listening and see you soon.